Hey, what's happening, guys? I got something new in the mail yesterday from DFRobot. I want to share it with you guys. It is, you can see the SKU number there. DFR0453, and it's called the Curie Nano. So, what this is an Arduino 101 in a small form factor, and this is a pretty cool board. So let's zoom in there and have a better look. Let's get even closer. What do you say? Pardon me bouncing the camera all around here. Okay. So now that we're in there nice and tight, we can get a better see of what's going on there. So this is the board, and it's, it's relatively small. It's about 2 inches by 1 inch. And as you can see here, we have a combination Wi-Fi Bluetooth antenna. And this is the Intel Curie module. This is the brains of the system. Got a couple LEDs there. We got a reset switch, micro USB. Not quite sure what that port is there yet, but we'll figure it out. So the specs on this thing are pretty impressive. Like I said, the microcontroller on board is the Intel Curie, and it's 3.3 volts, but every output pin is 5 volt tolerant. Very nice. Voltage limit is going to be about 17 volts. There are 14 I/O pins. 4 pins provide PWM. It has 6 analog inputs, up to 20 milliamps of current per pin, 196K of flash, 24K of SRAM, 32 megahertz, and that built-in LED is on pin 13. Now, it also features, like I said, the Bluetooth, but a 6-axis accelerometer gyroscope. And this one also has, this one being from the one from DFRobot, also comes with a compass built in. Now, another thing this thing has with that accelerometer stuff is knock detection, tap detection, and it also does gesture controls. The only thing you need to do to use this in your Arduino environment is to add to your board's definition folder. Just go into boards manager and search Intel Curie, load that up, and you'll be good to go. So I am going to solder on some header pins so we can put this bad boy into a breadboard, and then we'll have a little play. What do you say? Okay, so everything is soldered together. Powered it up, plugged it into the computer, and uploaded the Blink sketch. And you can see we've got a nice blinky LED. Now, one thing it did say in the documentation for this is when you reset it, it takes about 10 seconds for it to start running the code again. That only seemed like about 2 or 3, so don't quite know. But it is something to be aware of. Alright, so now I've uploaded this sketch, and this is a demo sketch called Accelerometer Orientation, and it's out of the Curie IMU library that's installed by default when you install the Curie board. So we're using the camera here instead of a screen capture because I want you to be able to see both the serial port and the board itself. There's really nothing much going on here, except it's going to get a orientation of the board, which you can see right here from this read accelerometer section. And then it's going to report that position to us down here. So all we need to do is open up the serial port. I think I have to reset it. Hold on. Okay, all right. So you can see here, initializing IMU device, connector down, MCU up. So that means the microprocessor is up. And here's the board. This is the MCU. These are the analog pins, and these are the digital pins. So if I go like this, you can see now it says connectors facing down, connectors facing up. Now our digital pins are up, and then if I swap it around, our analog pins are up. And if I turn the whole thing upside down, you can see MCU is down. So I hope you can see how this would be very, very useful. I mean, you can take that string and do whatever you want with it, but this will tell you the position of this board in space. Well, hell, that's the beginning of an inertial measurement guidance system right there. I think it's pretty cool. So last thing we want to look at here is just the pins that we have available. Now our connector, since this will work as a HID device, will come up as serial 0. And these two pins here, TX and RX, will come up as serial 1. Now we have these digital pins, D2, and you'll notice our squiggly marks on D3. Looks like D4, D5, and D6. Those are our PWM pins. Maybe. Okay, there's none on D4. The other PWM pin is up here, D9. There's our LED. Over here we have digital 20. Then we have our analog pins. And what's nice is they've kept the same I2C output here. SCO and SDA are an A4 and A5. We have a reset pin. We have ground pins, 3.3 volt, 5 volt, another ground pin, and a battery pin so that you can take this thing and operate it off of a battery. Here we have an air LED, a communications LED, and our reset button. Remember, there is a slight delay when pressing that reset button. And guys, that's a basic introduction to this, which I think is a really, really powerful board, and it's integrated perfectly into the Arduino environment. So there's nothing new to learn except some new commands from the libraries you're going to use. Very nice. Again, this was sent out by DFRobot, free of charge for our consideration, so I'd like to thank them for it. And I will put a link down below where you can purchase this. I think it's about $37. Yeah, granted, it's more expensive than buying an Uno or a Nano, but you're getting a whole lot more here. So, that's it for today. I really hope you guys enjoyed this. And if you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons. That's it. I'm out. Peace.